Good afternoon, sir. Thank you very much for your time. I would like to go straight away into the presentation of the assignment. What we have tried to do is fulfill some of the requirements uh, as required in the assignment. So I'm going to present a few of it, but for much more details and technical, everything has been well planned and documented. I'm going straight away into my contribution. We begin off with an IP address 192.168.1.0. This IP address we want to subnet and divide it into three different categories because there are three different offices in Kuala Lumpur. The first office is the sales office, the second one will be the engineering, and the third is the financial office. So these three offices, we want to logically separate them. Now there are two ways, of course, the subnet and also VLAN. But what we've done is implement both. So we're using variable length subnetting mask in order to get these different net IDs, and also using VLAN to logically separate them and also increase performance by reducing broadcasting packets, isolating them to only one specific broadcast domain and not to have all them broadcasting on the same domain. So as you can see on the table, we have three net IDs, starting off with 1.0. 1.0 is serving 50 employees in the sales office. However, we have 64. The 14 will be for scalability and future use. Moving on, we have the 64 and then the 80. We assume that the engineering will only need 10 computers or 10 IP addresses, and that the financial office will only need 6. Now, implementing VLANs, what we have is VLAN 10 for sales, VLAN 20 for engineering, and VLAN 30 for finance. This is going to help isolate the different offices as required by the office, by the documentation or our client. So they will have no direct communication, and this is going to require them to use inter-VLAN communication or inter-VLAN routing. And how is this achieved? Well, there is one router. It's an internal router with an internal port, and this port will have to be configured to sub interfaces, meaning that we can have multiple interfaces or multiple gateways on one specific interface, and that is an amazing thing. However, the cable or the interface which is connecting to the router must be trunk so that it can support. So it must be changed from an access port to a trunk port so that it can be able to support these different types of VLANs. So this is basically how we configure the sub interfaces by saying .10. So .10 will be referring to VLAN 10, and then we have the encapsulation .q, meaning that the encapsulation .2 is just a protocol which tags frames. As the frames are moving from one network to another, passing through the trunk, they are tagged so they can be recognized. So some you have like some tags which are not, some packets which are not tagged, they can still pass. I believe they are considered as through the native VLAN. Now, also because we have 50 different employees in the sales department, we've decided to make the job of the network administrator a bit easier by implementing DHCP, which is Dynamic Host Configuration Protocol. And this protocol will automatically allocate IP addresses to all the hosts which are connected to him based on the net ID. So we have 3 net IDs. And as we go on to Packet Tracer, I will demonstrate how this has all been done and how it's working. Another interesting thing to notice is that all it requires is a pool name. In this case, we have 3 different DHCP pools configured on one router. Then we have the networks, we have the default gateway, and the DNS server. Okay, apart from that, we'll talk about port security. We look at the dynamic port security. We look at the violation and how it all come together in real life. So moving on to packet tracer, one of the first requirements with the assignment is that client stations referring to sales, engineering, and finance, they must be able to access the web server. And I'm going to demonstrate this a little bit later on. So what I've just said is here we have configured VLAN. So if I enable and show VLAN, you can see that there are three different VLAN: sales VLAN, engineering, and finance. VLAN 10, 20, and 30. All of them are active, and there is no port which has been assigned to them. However, this switch, if you say show VTP status, this switch is also a server. So it acts as a server and in a domain of company A. You can see how all this comes together, because this one being the server, switch 2, switch 3, and switch 4 are all going to be clients. So they all receive the settings which have been here. So all the VLANs which have been set on this switch 1 will also appear on this router. So show VLAN. As you can see, this is the sales department. It's sales VLAN, and all the ports have been switched to, or allocated, or assigned to sales VLAN. This is the same for all the other show VLAN command. This is the same for all the other VLANs. VLAN 20 with all the ports connected. So in order to achieve routing from this department to the web servers or to the DMZ, we've used RIP version 2 for routing as a routing protocol. RIP version 2 show route. You can see we've used RIP version 2 to route, and I'm going to demonstrate. And before that, the requirement is that the client should be only allowed to use HTTP and HTTPS, and so these other services have all been shut, apart from the FTP, which is required for the web server. DNS here has been turned off, so we just turn them off here graphically. And this server has been assigned a static IP address so that the IP address does not change. Okay, so using PC1, we're going to ping network 172.16.10.5, which is our web server. And if everything has been well configured, it should work. Sorry about that. If everything has been well configured, it should work. Yeah, it's successful. Okay, that's good. So here we can see all the packets. The first time around 25% was lost, now 100%. And using the DNS server to translate the IP address, because people cannot remember IP addresses which are 32 bits. Okay, so we've used the DNS server which translates the IP address. It's sitting right over here in services. The DNS server is translating this domain name to this address, and we can add multiple addresses. So as you can see, we're able to ping the web server. I believe we ping it from Singapore. Now we can try and ping it from the engineering department, www.company.com. Spelled it correctly. There we have it again. So it shows that it is able to ping, that it is able to work. So from Singapore to Kuala Lumpur, the routing protocol is open shortest path first. Open shortest path first. Open shortest path first, which has been configured, and as you can see, what we've done here is add an extra router. This router is just to represent the many different interconnected routers where our packets can travel through. However, we'll discuss about the VPN a bit later. So having shown that we're able to ping or communicate with the web server, it is also a requirement that it says that client stations must be able to check their email on the email server at the DMZ, and the mail server should be able to receive mails from external hosts over the simple mail protocol. So coming to the mail server, we have enabled the simple mail SMTP. It's enabled, and you can see the domain name company.com with all the different employees which have been set with a password. So what we're going to try and do right now is from Singapore. Actually, we can do it from here. From here, we try to ping. Okay, so this one is not set. Here, we try to communicate with the server. So I'm going to compose an email to Amy. So I will say Amy at company.com. Say hello Amy, hi Amy, and send. As you can see, it's a success. Send success. It has sent to the mail server 172.16.10.4. And if we go into configuration, you can see the incoming mail server has been set to the IP address of the mail server. The outgoing mail server as well, 172, it's the same. These are all actually been configured statically on the servers. So if we come to Amy and just see whether we can communicate by receiving the mail, we receive, there we go, we have hello Amy. So just demonstrating that the requirement of mail is also working. So we're able to ping the web server using HTTP HTTPS with DNS for the domain name to be translated. Now, one other requirement is that the client should be able to send and receive files on the same server, which is the web server. So basically, the web server also serves as the FTP server. However, not all the departments should be able to use that service of FTP, namely the sales and engineering. So I'm going to demonstrate how we've used an access list to prevent this network from accessing FTP server. So the access list which has been configured is access list 102. 102 showing that it's an extended access list. An extended access list actually gives us the flexibility to block specific services or applications, and rather than its counterpart, the standard access list. So the access list has been configured on router 2 and has been set on port FA0/0 as the inbound. let's just enable, say show running config, and here we'll be able to view the access list. As you can see, the access list 102 denies TCP from the source 192.168.1.0, which is the sales department. So it is denying FTP service. You can see this is the destination. This is the destination address with its wildcards. This is the destination address. These are the wildcards. So what I'm going to do is demonstrate. We try to FTP 172.168.10.5. It tries to connect. In fact, if it connects, it means that the connection, all the configurations were not correct. Okay, so therefore there it has rejected. It's disconnecting from FTP server. It is not being able to establish a connection. However, if we try from the Singapore side, we try to FTP 172.16.10.5 172. There you can see it is quickly establishing a connection, requesting for the username and password. And if I press the question mark and enter, we have those services, some privileges you can see. We have rename privilege, delete privilege. Okay, so this is because there is no access list preventing or blocking the Singapore from accessing or sending and receiving files via FTP. However, we have files we have configured to block the 192.168.1.0 network from reaching them. Okay. Furthermore, so we have shown the emails all working. The clients are able to communicate with the server, the DMZ. And one more beautiful thing is port security. Port security allows for first of all, physical security. So there are actions which can be set to promote physical security. For example, this switch over here, switch 2, it has a total of 24 ports, and the ports which are currently being used is port FA01 up to 5. Therefore, from actually up to 6. So from 7 to 24, all of them are administratively shut down, meaning that you can plug on and it is completely shut down. It's off. It will not be turned on. This is good to prevent people from malicious attacks or people from trying to connect onto your server and onto your network. However, there's another configuration which is here. Show port security. You can see these three have been configured with port security. The first one, the security violation, the security violation is set to protect, and the FA05 and FA03 are to shut down, meaning that if a computer is connecting to that port will shut down. This is because it listens and reads or learns the MAC address of the host which has been connected to it. So at the initial configuration, it learns the computer or the node which has been connecting to it. It will learn its IP address and then store it in a table. So if another IP address connects, another computer connects, it will read that MAC address, and if the MAC address does not match the one which it has dynamically been assigned to, then the connection just shuts down. So I'm going to demonstrate how that works. So we're going to introduce another computer. So we can just maybe say this one, say attacker. Okay, so we can just use FA. This is 05. Okay, so we disconnect and connect to its interface. I'll speed the time. So it's connected, but as soon as it tries to establish any sort of communication, for example, trying to request for an IP address, it should automatically be shut down, as you can see. So layer 2 port security is working perfectly fine. In fact, it has been configured on all other switches. Enable show port security. It has been configured on all other switches to ensure security. The ports which are not being used have all been shut down. So we're using RIP version 2 to route between here. This router basically learns the net ID or the network of the networks which are directly connected to its ports, and then this router will also learn the networks which are connected directly to him, and they'll be exchanging their routing tables every 30 seconds. It also depends on the configuration. Every 30 seconds can also slow down your network. So, sorry, for the final part is the VPN. Of course, VPN is probably a very complex topic. However, it is probably the best security which can be implemented from Singapore to Kuala Lumpur in order to secure the packets which are traveling through the internet. So to secure those packets, we implement VPN. A VPN consists of a lot of different algorithms and cryptographies. And for example, we have to first enable the internet key exchange policy on the Singapore router, and also on this router where we try and establish a tunnel. So we enable the internet key exchange policy, and then IPsec. So we're saying that IPsec is an open framework that allows the exchange of security protocols as new encryption algorithms are developed. So first thing, we enable the crypto ISAK, which is key management protocol. It's an internet associated key management protocol. We enable that. We give it a policy number. So I'm just going to show some of the settings which have been done. Show crypto show crypto map. So show crypto map is one of the commands which will show you the map. So we've created a map by the name of Singapore, or Singa map 10, and these are its peers. You can see there's an extended IP access list. This access list permits must be configured on both routers, and it allows for IP connection between this network and the 172 network. So between 192.168.10 network, this is what this access list allows. If we use another show crypto, leave SA, is it SA? Show crypto SA. Yeah, so here you can see the destination, the source, the state, and the status actually is active. Show crypto policy. So here on the policy, you get to see the different encryption different encryptions that have been implemented. For example, you have the encryption algorithms. We're using advanced encryption standard, which uses 256 bits. Since 256 bits for encryption, we have the hash algorithms, which is secure hash standard. The authentication methods, which is pre-shared keys. We have the Diffie-Hellman group 5, um, and also if we go on to, you can see the encryption algorithms default protection suite encryption algorithm data, which is DES, data encryption standards. Here's yours the hash algorithm, which is secure hash standard, authentication method. um, let's one more command, show crypto crypto. This one I've already shown. So basically, these are some of the configurations for VPN. They are a bit overwhelming, I must say. Most of them we got, of course, from the tutorial class, and however they are working, and the connection between the offices are working using VPN to secure and encrypt the data which travels. Hopefully, as we grow, we learn more. And thank you very much, sir, for your time. Thank you. Goodbye.